Okay, now today we are going to discuss about the property called as electromagnetism. So electromagnetism is a special property, a special phenomena in physics. So before entering into the electromagnetism, let us see what is a magnetism. Magnetism is a property of some of the substances. It is a special property of some of the substances. The property is nothing but attracting of some other substances like iron, cobalt, nickel. Such a phenomena, such a property of substances, special property of a substance of attracting some other substances like iron, cobalt, nickel is called as a magnetism, and the substance which shows such a property are called as magnets. Once again, the substances which show the special property of attracting some other substances like iron, cobalt, nickel are called as magnets, and the property shown by such substances are called as is called as a magnetism. Okay, so iron, cobalt, nickel, but this property is limited to some substances only, not for all the substances. And these magnets cannot attract all the other substances. It can attract only the substances like iron, cobalt and nickel and their alloys. Okay, such a phenomena, such a property of substance is called as a magnetism. Let us discuss about the properties shown by the, means characteristics shown by the magnet. Let us see the characteristics shown by the magnet. So one of the properties, cloth. So one of the properties, a magnet has two poles. One is north, other one is the south pole. Every magnet has two poles, one is north and other is south. So these magnets are available to us naturally, or we can make these magnets. The naturally occurring magnets are called as lodestones. Naturally occurring magnets are called as lodestones, whereas we can make these magnets artificially in the industries or in the laboratories. Okay, once again, the magnets which are available to us, which are available in the nature are called as natural magnets. The other name for the natural magnets is nothing but the lodestones. And we can make our own magnets also. Means we can synthesize the magnet. The magnets which are synthesized by us are called as artificial magnets. So these artificial magnets may available to us in different shapes. So if it is like a bar, chocolate bar, it is called as a bar magnet. Have two poles, one is north pole and other one is the south pole. And if it is like a circular disc, this is disc magnet or circular magnet. And donut or polo magnet, there is a gap. This is a donut or polo magnet. And these are the U-shaped magnet. This is a U-shaped magnet. And we have the horseshoe magnet also. These are the different types of magnets we have. These shapes are for these magnets because they have a specific shape for these magnets because they are man-made. They are artificial magnets. And each of these magnets, whatever the shape they have two poles. One is on this side, other one is on the other side. North and south, north and south, north and south. So like that, every magnet has two poles. One is north pole, other one is the south pole. North pole and the south pole. Why you named them as a north pole and south pole? Why don't they represent it as a east and west? That is because of the directive property of the magnet. When you suspend a magnet, ante veladiste oka bar magnet, any magnet, if you suspend it, particularly bar magnet, if you suspend it and veladise odileste and make it to comes into rest, then it always directed towards the north and south. So the pole which is directed towards the north, the geographical north, bhumi yokka north. So that is named as a north, and which directed towards the south of geometrical or the earth is nothing considered as a south pole. So for a magnet has two poles. One is north, other one is the south pole. So magnet has two poles. One is north pole and other is the south pole. So this is one word. This is called as a directive property. Even if you suspend this magnet, it always comes into the direction of north and the south. And another one is there. This is called as a pole property. So this is a magnet of bar. I have taken this one. I made it into pieces. I got two pieces. But even it is become into two pieces, these two pieces both have the north and the south. Each piece has two poles. Even if you break it into number of pieces, each piece has north and south. Each piece has north and south. North and south, north and south, north and south, north and south. So like this, how molecular the magnets, even the molecular magnets means very smaller even in size. They have two poles, one is north and other one is the south poles. So this is called as the pole property of magnet. Every magnet has two poles, one is the north, other one is the south. Okay, now means from this what we can say that there is no single pole magnet existed, isolated pole magnets, means no single pole magnets are existed. Even how smaller the magnet is, it has two poles, one is north and other one is the south. So now we go for the other property of the magnet. See, if you take a magnet, it has two poles. This is the bar magnet, one is north, other one is the south pole, as we know. And the other magnet also have north and south pole. These two are the two bar magnets we have taken. And each bar magnet has two poles, north, south, north. When you keep them near to each other, in this orientation, means one side has one end has south, other end has north, they attract together. They attract each other when the north and south are facing together. Whereas if you keep these two bar magnets in such a way that when the two like poles are faced together, then you cannot observe any attraction. Instead of attraction, you feel the repulsive force. When you observe the repulsive force, when the two poles are of same type. When you observe the attractive force, when the two poles are of opposite type. Okay, so when two poles are of opposite type, when two poles are of opposite side, they attract together, face together, they attract. When two poles of the same type face together, they repel each other. So from this what we can conclude, like poles means north pole faces to the north pole, then we observe a repulsion. When north faces together to the north faces, when south faces to the south, they are like poles, therefore we feel the repulsion. Whereas when north points toward the south, whereas south points to the north, you feel the attraction. So attraction and repulsion are the forces between the two magnets. So two magnets attracted or repulsion depends upon the type of the force they face together. So that is nothing but one of the properties shown by the magnet. Okay, and one more property of the magnet, let us discuss. Right. And now I said magnetic substances. What are magnetic substances? The substances which are attracted by the magnet are called as a magnetic substances. Substances attracted by the magnet are called magnetic substances. So we have several examples. Already at the beginning of the class I said iron, cobalt, nickel, and their alloys. Alloys means mixture of these metals with other metals. They are the magnetic substances because they are the attracted by the magnet. So once again, the substances attracted by the magnet are called as magnetic substances. Examples for the magnetic substances are iron, cobalt, and nickel. And their derivatives means their alloys also can be attracted. So for all these are the magnetic substances. Whereas some substances are cannot attracted by the magnet. So those substances are called as non-magnetic substances. So substances which are attracted by the magnet are called magnetic substances, whereas substances which cannot attracted by the magnet are called as a non-magnetic substance. We have several examples for the non-magnetic substance like plastic, rubber, paper, glass. All these are the examples for what type of substances. These are the substances of non-magnetic, whereas iron, cobalt, nickel are the substances of magnet. These are the magnetic substances and these are the non-magnetic substances. Okay, now let us go for the other property of magnet. Is it audible? Say yes or no please, so that I can understand. Is it audible? Dikshita and Santosh, Meghana, and who are watching this, please text me. Audible? If audible, say yes. Right. Now we go for the another property of magnet, magnetic induction property. What is induction? Induce. Induction name says that induce. What we induce? The magnetic property we induce. On what we induce this magnetic property? Right. We induce this magnetic property, means property of attraction, in the magnetic substances. So that is the case of magnetic induction. Right. So where you can observe this magnetic induction? Let us see. Let's take a magnet of bar, north and south, north pole and south pole of a magnet. If I keep an iron nail near to this bar magnet, iron nail near to this bar magnet, iron nail near to this bar magnet. So what happened? If you keep this iron nail far from the magnet, you didn't see any attractive property. Even it is a magnet and even this nail is made up of magnetic substance iron, but you cannot find any attraction. Whereas we go for the okay, this is the magnet and this is the magnet substances. They kept far from each other, but we didn't find any attractive property between these two. Why? Because they are far from each other. Okay, whereas if you keep this nail near to the magnet, then it is attracted. It is not required to touch this magnetic substance to the magnet. మనం తీసుకెళ్ళి magnet కే తాకించాల్సిన అవసరం లేదు. Even if you keep some this magnetic nail near to some area near to the magnet, at some area near to the magnet, this magnet can attract this magnetic substance, that is nothing but iron made up of magnetic substance, attracted to the magnet. So means the force is exerted by the magnet on the magnetic substance without in contact. So that's why we can say the force exerted by the magnet is called as a field force. Field force means a force without any contact. A force without contact is called as a field force. So a magnet can attract a magnetic substance, means any substance made up of any article or anything made up of magnetic substance. Without in touch with the magnet, it can attract if you keep it near to the magnet. So means what the force means, a magnet is attracting force on this, is a magnet is keeping some force on this magnetic substance. That force of a magnet on the magnetic substance is called as a field force or force without contact. So that we learned in the 8th class. So this magnetic field force, field force is due to magnet, hence it is called as a magnetic field force. This is the magnetic field force, the force exerted by the magnet on a substance kept near to it, that is called as a magnetic force. That is also called as a magnetic field force. Right. So what? Now what happened? So okay, this magnetic nail is attracted to the magnet. Now this is the magnet and this is the nail made up of iron. They are in touch with each other because of the force exerted by the magnet on the magnetic line. Whereas if you keep alpine is also made up of some steel, means a derivative of iron. It is also a magnetic substance. So alpine, if you keep to the end, if you keep and touch it to the other end of the nail, it will be attracted to the nail. So actually nail is not a magnet, కానీ అదేంటి magnetic material. So magnetic material cannot attract other magnetic material. Magnet only can attract the other magnetic materials. But a magnetic material అంటే ఒక ఐరన్ నెయిల్ తనకు తనగా ఈ అల్పిన్ని అట్రాక్ట్ చేసుకోలేదు, బికాస్ ఈ రెండు మ్యాగ్నెటిక్ సబ్స్టెన్స్ ఇంకో మ్యాగ్నెటిక్ సబ్స్టెన్స్ని అట్రాక్ట్ చేసుకుంటుందని ఎక్కడా లేదు. బట్ ఈ మ్యాగ్నెటిక్ సబ్స్టెన్స్ నెయిల్ ఇన్ టచ్ విత్ ద మ్యాగ్నెట్ అయినప్పుడు మాత్రం వెన్ ద magnetic nail means nail made up magnetic substance is in touch with a magnet, it is able to attract another magnetic material, means another thing which is made up of magnetic substance, that is nothing but alpine. అంటే తనకు తనగా అట్రాక్ట్ చేయలేనటువంటి ఐరన్ నెయిల్ మ్యాగ్నెట్తో ఇన్ టచ్ ఉన్నప్పుడు ఇట్ కెన్ అట్రాక్ట్ ద సేఫ్టీ పిన్. వై అంటే వెన్ ఇట్ ఈస్ ఇన్ టచ్ విత్ మ్యాగ్నెట్ యాక్టెడ్ యాజ్ అ మ్యాగ్నెట్. Why? Because of the influence of the magnet on the nail. That influence of the means magnetic property is induced to the nail by the magnet. So such a property shown by the magnet of carrying forward its property of attraction to the material, magnetic material which is in touch with, is called as a magnetic induction. దాన్ని మనం మ్యాగ్నెట్ అన్నారు. ఏదైతే అయస్కాంత పదార్థానికి అయస్కాంత తత్వాన్ని ఇచ్చిందో ఆ దృగ్విషయాన్ని మనం ఏమంటామంటే వీ కెన్ సే దట్ యాజ్ ఎ మ్యాగ్నెటిక్ ఇండక్షన్ అనమాట. నౌ అల్పిన్ ఈస్ అట్రాక్టెడ్ టు ద నెయిల్ because the nail is in touch with the magnet. If no contact between them, if you remove the contact bit, after some time this falls down, alpine falls down from the nail, because nail loses its magnetic property because it is not in touch with the magnet. So this is the case of magnetic induction. Okay, now we go further. These are all the concepts of magnet. Now the most important concept of the magnetism, then we go for the electromagnetism. Let us discuss what is the important property of the magnet. Now now let us see this is the magnet, north pole and south pole of the magnet. North and south of the magnet. what happened? Now we understand that there is some force of this magnet now is around its ఏదో కొంత ఫోర్స్ దాని చుట్టూ ఉంది. సో లెట్ us discuss about the what is the magnetic force. That is magnetic field force. Let us study how the magnetic field force is there. Are you able to see the magnetic field force around it? ఎంతవరకు తను అట్రాక్ట్ చేస్తుందో మనం చూడగలమా? No. Magnetic field force is invisible. We can't see, we can't feel through eyes. But how can we judge up to which area its effect is there? But we know that its effect is limited to some area around it. Let us see how it's means up to which area it is its effect is there. So in the previous classes we have conducted an experiment. A magnet we kept on the white paper and we sprinkled some iron filings, and on tapping these iron filings comes into an alignment such a way that around this, I think you have an idea about the iron filing, arrangement of the iron filings around the iron filings around the magnet. So you can see such a pattern of arrangement of iron filings around the magnet. Okay, these iron filings, the area where these the area around the magnet where these iron filings are arranged in some particular pattern, that area is the visual appearance of magnetic field. We can't see up to which the magnetic field, ఎంతవరకు magnetic field ఉందో మనకు తెలియదు. But now it is difficult to imagine, but through this experiment we can say, at least we can say up to this area its effect is there. So by this way, by spraying the iron filings, we can show up to which area the effect of magnetic field is there. In order to study this magnetic field well, we have to do an activity to study about the magnetic field force. How to do such an activity? And we have an instrument called as magnetic compass. Magnetic compass works on the directive property of the magnet. So magnetic compass is just like a circular having a needle which always points towards the north and the south. A needle has north and south. This needle is made up of magnet. One end of the needle is of north, other one is south. An arrow represents the north and a dot on the other side represents the south. So a magnetic compass has a needle, one is arrow, one end has an arrow, other end has a dot south, arrow is north. If you keep this magnetic compass on a paper far from a magnet, which is kept far from magnet, and a magnet it always points towards the north and south. That is the because the needle is made up of magnet, as we know that magnet always have to show the north and south directions. So magnetic compass. With this compass, I want to represent the magnetic field area, which is actually imaginary. So to make it visual, to make it visual appearance of this magnetic force, I want to draw a lines of magnetic lines with the help of compass. How we have to draw the magnetic lines? So take an activity. Let us see the activities. Think it as I have no magnet and magnetic compass. Consider them as a magnet and magnetic compass. So let us see this as a magnet. Okay, this is north end and this is the south end. So this is the compass. Keep the magnet at the center of the paper, and this is the north and this is the south. Cap, north and bottom shaft. Keep the compass at this side. Then what happen? As it is north, so south has to come in contact. South of the needle should be points towards the north of a magnet. South ikkadiki vastundi because the north kabatti ikkada south. Then north emoutundi ikkadiki vastundi. Now make a point. Keep the compass here. Point cheyandi where the north is there. Now move this compass again. Keep at the other end. So at this dot. Now point this again. So now this continue like this. What happened? This is the north and this is the south. So what happened? This is north and this is the south. So what happened? Now continue this. Continue this. So continue drawing points. Itla cheskuntu velte that come. So join these dots. Is it straight line or curvy line? It's a curvy line. So continue, change the position. So change the position. Continue it. Draw on either sides. Like so. Draw it on either sides like so. ఈ విధంగా రెండు వైపులా చేయండి. Again join these dots. You get again a curvy line. So in the same way do it on the other side also. So this is north and this is south. Manaku telusu south is towards the north. Okay, point here and keep the south ikkada exact ga position and then comes here. So like this, point them and point them. So right. So join them continuously. Means you get a, if you continue in the same way on either sides, we get a curvy lines on either sides. This curvy line shows that the magnetic field. Okay, so like this we get some curvy lines. Manaku konni curvy lines vastu untayi anamata. It's not a straight line. So magnetic field force is around the magnet. It's not straight. These are called as a magnetic lines. 1 minute. So this is the magnet and we draw, and this activity we get some lines. One minute. So it's a trial na, first trial na. So we have some problems like this. ఇక్కడ కొంచెం ఇబ్బంది అవుతుంది. సరే, దిస్ ఈజ్ నాట్ ఏ బోర్డ్, జస్ట్ అ ప్లాంక్ పట్టుకొని నేను ఏదో చేస్తున్నాను. అర్థమవుతుందా? వినిపిస్తుందా మీకు? హలో, ఆర్ యూ ఏబుల్ టు హియర్ మీ? సే yes. Say yes. Only 3 members are watching. Right. Only 3 members are in live. I don't know about the remaining. Give your attendance, please. Give your attendance, please. Hello. Yeah. Okay, so magnetic field lines, north, south. See, now these are the magnetic field lines. If you observe these magnetic field lines, the spaces between these are called as magnetic field lines. If you observe these field lines, as you go far from the magnet, the space between the lines is more, whereas near to the magnet the space is less. Space is more. What it indicates? More space means less magnetic property. Less space means more magnetic property. So magnetism is very near to the magnet. Magnetism is, the property of magnetism means the field force is more. The field force is more near to the magnet, whereas field force is less far from the magnet. As you go far from the magnet, the space between the lines, magnetic lines, these are called as magnetic lines. The space between the magnetic lines increases, whereas the space between the lines is less near to the magnet. Less near to the magnet. Okay. Now, what happened? Now this line shows the strength of a magnet. Now let us see the direction of magnetic force, magnetic field force. At the outside of a magnet means a force has a direction. You know direction. Force is a vector quantity. So here magnetic force is also vector quantity. It has a magnitude and direction. As you know, the value of force, magnitude varying from one place to other way. Here more, here the less. Here more, here the less. As you go far from this, as you go far from the magnet, the magnetic magnitude of the force is decreasing. Near to the magnet, magnetic field force is more. Okay, means what? The magnitude value is varying. At the same time, direction of magnetic field also changes from one point to the other point. So how to find the direction of a magnetic force at a particular point in the magnetic field area? So let us see once. Suppose this is the point where I want to find a magnetic field force. Draw a tangent. Tangent means it's like 90 degrees. A line passes through that point because this is a curve. Mainly field lines are the curvy lines, means only one ray can pass through a particular point in that curve. So this is called as a tangent. So tangent drawn at the point is nothing but the direction of the magnetic force at that point. Tangent drawn at the point. See, let us see, this is the direction of the magnetic field at this point. This is the direction. Is the direction changed or not? Yes, it is changed from one point to the other point. Therefore, magnitude is not constant and direction is also not constant. Hence, we can say that magnetic field force is a vector quantity and it varies from one point to the other point. So direction of a magnetic field at a point is given by the tangent drawn at the point. Tangent drawn at the point gives the direction of the magnetic field force. Whereas overall magnetic fields, what is the direction of the overall field of the magnet? So that we consider as the direction of the magnetic force, overall magnetic force, is considered to be from north to south, outside of the north to south, outside of the magnet. So magnetic field force outside of the magnet is from north to south. The direction of the magnetic field force outside of the magnet is from north to south, whereas inside of a magnet it is from south to the north. From south to the north. Outside these are curvy, whereas inside they are parallel. Inside these lines are parallel to each other, whereas outside they are curvy lines. Outside it is from north to south, whereas inside of a magnet it is from the south to the north. So inside south to the north, outside the direction of magnetic field is from north to the south. So by this way we can we can say about the magnetic field can be studied with the magnetic field lines. Magnetic field lines. Okay, magnetic field strength is not constant, it varies from one place to other place. Magnetic field direction is also not constant, it varies from one point to other point. Whereas overall magnetic field force is, overall direction of the magnetic field force is from north to south outside, whereas south to north inside. And these magnetic lines are curvy outside of the magnet, whereas parallel inside of the magnet. Now let us see, let us introduce two more terms in the case of a magnetism. Magnetic field, to describe the magnetic field. Strength of the magnetic field, we need to learn two more terms. What are the two terms which we use to learn about the magnetic field force? Magnetic field force గురించి నేర్చుకోవాలంటే ఏంటి ఆ పదాలు మనకు కావాలో మనం తెలుసుకుందాం. చాలా మంది తక్కువ మంది అటెండ్ అయ్యారు. సో ఇది టెస్ట్ ట్రయల్, యాక్చువల్గా ఎక్కువ మంది అటెండ్ కావాలి. రైట్. సో ద ఫస్ట్ టర్మ్ ఈస్ magnetic flux. Magnetic flux is a magnetic flux is a physical quantity which describes magnetic field. This magnetic flux is represented by symbol pi. This is the pi in mathematics. Pi is a symbol we use to represent the magnetic flux. What is the definition of magnet? It is nothing but number of lines. Number of lines of number of magnetic lines in a given area, whatever the area it may be. So the number of magnetic lines in a given area, suppose area is A. How many lines are there? Count the lines. If it may be 1 square centimeter or 10 square centimeter, whatever it may be, 100 square centimeter, so whatever the area it may be, how many lines are there in that area? That is nothing but magnetic flux, denoted by the letter pi, is measured in the terms of Weber. Weber తో మనం కొలుస్తాం అన్నమాట. Once again listen to me. Magnetic flux is nothing but the number of magnetic lines in a given area, whatever the area may be. It may be 1 square centimeter or 10 square centimeter or 100 square centimeter or 1000 square centimeter. How many magnets? If you count the number of magnetic lines in that area, so suppose these are the magnetic lines. So count. Suppose it may be 1 square centimeter or 10 square centimeter, whatever it may be the value. But how many are there? 1, 2, 3, 4, 5. So 5 is the magnetic flux. Is measured in the units of Weber. So magnetic flux is represented by a symbol pi, measured in the units of Weber. It is nothing but the number of magnetic lines in the given area. Area may be of any. I think you understand well. Now we have to introduce one more, that is called the magnetic flux density. It is nothing but a magnetic field. So magnetic flux density determines the strength of a magnet. Right. That is nothing but a magnetic field. What is the magnetic field or magnetic flux density? Magnetic flux density is represented by letter capital B. Capital B తో మనం రిప్రజెంట్ చేస్తాం అన్నమాట. Magnetic flux density. Magnetic flux density. Flux density. What is the definition of magnetic flux density B? ఏంటి definition? ఎట్లా చెప్తాం? It is nothing but as same as magnetic flux. Number of magnetic lines. Number of magnetic lines in unit area. It is important. In any given area is flux. In unit area is nothing but the flux density. Magnetic lines in a unit area. Unit area. In unit area. Whereas previously we discussed in a given area. But here it is nothing but a unit area. Unit area is B. Given area is pi. So this B is mathematically given by the pi by A. How you got this? B is equal to pi by A. I said now, flux is number in a given area. flux is nothing but magnetic lines in a given area. This is 1 unit. So ఒక యూనిట్ కి ఏమవుతుంది అంటే pi by a. సో అంటే ఒక ఎగ్జాంపుల్ తీసుకుందాం. 10 apples cost 50 rupees. 1 apple cost ఎంత అంటే you can say simply 5 rupees. How? 50 by 10. 50 by 10. 50 by 10. In the same way, A అనే ఏరియాలో ఇన్ని లైన్స్ ఉంటే ఒక యూనిట్ ఏరియాలో ఎన్ని ఉంటాయి pi by a. ఒక యాపిల్ కాస్ట్ అంతా 50 by 10. రైట్. సో వన్స్ అగైన్ 10 apples cost 50 అయితే 1 apple కాస్ట్ ఎంత అవుతుంది 50 by 10. దట్ ఈస్ నథింగ్ బట్ ఇన్ ద సేమ్ వే ఏ అనే ఏరియాలో పై ఉన్నదంటే 1 యూనిట్ ఏరియాలో ఎన్ని ఉంటాయి pi by a. దట్ ఈస్ నథింగ్ బట్ ద b. సో b ఈజ్ ఈక్వల్ టు pi by a. యాజ్ యూ నో pi ఈస్ మెజర్డ్ ఇన్ వెబర్ and area you know meter square. So Weber by meter square is the unit of flux density, magnetic flux density. Weber by meter square. Weber meter to the power -2, or simply Tesla. Tesla is the unit of magnetic flux density, or Weber by meter square we use to measure the magnetic flux density. And we have another unit also there, GAUSS, gas. Gas is also used to measure the magnetic flux density. So ఇది మనం మ్యాగ్నెట్ గురించి, మ్యాగ్నెట్ యొక్క ప్రాపర్టీస్ గురించి, మ్యాగ్నెటిక్ ఫీల్డ్ గురించి, హౌ టు మెజర్ ద మ్యాగ్నెటిక్ ఫ్లక్స్. అంటే దిస్ ఫార్ములా వి యూస్ b is equal to pi by a, or pi is equal to ba. Pi is equal to ba. As b is equal to pi by a, pi is equal to pi by a, pi is equal to what? Ba. This is the formula we use when the angle between area and area taken and the magnetic lines is of 90 degrees. So once again ఒకవేళ యాంగిల్ మ్యాగ్నెటిక్ లైన్స్ కి ఏరియాకి మధ్య యాంగిల్ 90 degrees అయితే we use this formula. Whereas if there is an slant inclined గా ఉందనుకోండి, making some angle theta, then we use the formula pi is equal to ba cos theta. Pi is equal to ba cos theta. Pi is equal to ba cos theta, or b is equal to, then what happen? B is equal to pi by a cos theta. So these are the formulas to find the b. So if the angle between the lines and the area is 90 degrees, then b is equal to pi by a, or pi is equal to ba. Whereas any other angle means an incline, if they are then what happens? Instead of a, you take a cos theta. So ba cos theta. Pi is equal to ba cos theta, or b is equal to pi by a cos theta. So this is about the magnetic field, and in the next class we discuss about how our lesson is electromagnetism. Electric current, what is the relation between electric current and magnetic field, రెండింటి గురించి మనం నేర్చుకుందాం. ఓకేనా? ఇంతవరకు మనం ఈ క్లాస్కి ఇక్కడతో మనం ఆపుదాం. ఇది టెస్ట్ డే, అంటే ఫస్ట్ డే. ఏంటేంటి ప్రాక్టికల్ ప్రాబ్లమ్స్ ఉన్నాయో లెట్ మీ చెక్. నేను ప్రాక్టికల్ ప్రాబ్లమ్స్ అంతా పూర్తిగా అయిన తర్వాత దెన్ మనం ఇంకొంచెం ఎఫెక్టివ్గా క్లాస్ ఉండొచ్చు. టెస్ట్ ట్రయల్ అనమాట. మీకు ఎట్లా నెట్ సపోర్ట్ అయింది, ఎంతమంది కనెక్ట్ అయ్యారు, ఎంతమందికి ఇంట్రెస్ట్ ఉన్నారో లెట్ మీ చెక్ ఆల్ దీస్ థింగ్స్. అవునా? ఒకరిద్దరు వస్తే కంటే ఎక్కువ మంది వస్తే ఇంకా బెటర్గా ఉంటుంది. చూద్దాం. ఓకేనా? వినిపిస్తుందా? Bye.